All right, so what we're going to do here is we are now going to go the reverse. We're going to start with the sketch of a quadratic graph, and I'm going to show you how to identify the function from only 3 points. Okay, so one of the things that you're going to do, though, is given these 3 points, is you're also going to identify the 4th point. Okay, you can actually identify any quadratic function given just the roots and the y-intercept. Okay, so let's use this one right here. This one looks interesting. Yeah, we're going to use the y-intercept is 0, negative 9, and our roots are 1, 0, and 9, 0. Okay, so let's say that this is our parabola. Well, we're going to put a vertex point up here, although we don't know what it is yet. And so we're going to go ahead and draw our parabola. It's a little ugly, but so this is 0, negative 9, and this is 1, 0, and this is 9, 0. Okay? And so the first thing we're going to do, so given a sketch of a parabola, okay, with roots, or let's say with intercepts labeled, with intercepts labeled. Okay. All right, so the first thing we're going to do is we are going to identify the factored form of this quadratic function. So we're going to write f of x is equal to, and we're going to do a times, so a is going to be the lead coefficient. Okay, we don't know what the lead coefficient is, but what we do know is that this root here, 1, comes from the factor x minus 1. So what you, or well, let's not put x minus 1. Let's put x minus root 1, okay, and then times x minus root 2. So what you have to do is, for step 1, you just write f of x equals, and you're literally going to write the letter a, and then you're going to put parenthesis x minus, and then you're going to put the roots in here, okay? So we're going to put a 1 here, and then put the other root here. We're going to put a 9 here. And so what we have over here is f of x equals a times x minus 1 times x minus 9. Here's where we are so far. That's step 1, okay? And so now what we're going to do is we are going to, step 2, we're going to identify a, the lead coefficient, identify the lead coefficient a, comma, a, okay, by, here's what we're going to do, multiplying the roots, okay, and dividing them into, dividing that product, dividing into the y-intercept. Okay, all right, and so so that means the lead coefficient a is equal to the y-intercept, not the coordinate, just the y here, the negative 9. The y-intercept is divided by root 1 times root 2. That's it. Okay. So over here, what we're going to do is a is going to be equal to, the y-intercept is negative 9 divided by root 1 is 1, root 2 is 9, and 1 times 9 is 9. So we have negative 9 divided by 9, so a is negative 1. Okay? And so what we now have is f of x, and then we're going to replace a, is equal to negative 1 times x minus 1 times x minus 9, and we're done. Okay? Well, we're done identifying the function. Now note, we don't have to put -1, we can actually just put negative. So this is that function. But now what we're going to do is we're going to go ahead and distribute. So f of x is equal to negative. And now we're going to, for the next step, okay, step 3, distribute to identify the standard form, meaning the ABC form, standard form, the ax squared plus bx plus c form, okay? So we're going to go ahead and distribute here. X times x is x squared. X times -9 is -9x. -1 times x is -x. -1 times -9 is +9. Okay? And so what that is actually negative. Now, we're not going to do this negative until just a minute. So we're going to distribute that also. So we have x squared. -9x minus x is -10x. +9. And now, this is a -1 here. We have to distribute the -1 among everything. And so f of x is equal to -1 times x squared is -x squared. -1 times -10 is +10x. -1 times 9 is -9. And so this is our function for this. The last thing that we want to do is identify the vertex, which we already know how to do from the last part. Identify the vertex. Okay? And if you recall from the last thing we learned how to do when we were graphing the parabola, we said we needed to identify the vertex. We need the critical x, which is halfway between the roots, halfway. So if we add 9 plus 1, that's 10, divided by 2, that's 5. So we know that this vertex is at 5 comma something, or we could use negative b over 2a. So we already, now that we have this form, we can do negative b, which is -10, over 2 times -1, that's -2. So -10 divided by -2 is 5. So there we go. We've got our vertex. Okay. Well, we've got the critical x. Now we need to plug that 5 in, and we have this form right here. Okay. Now note we gotta do the opposite of it. Okay. So you can either use this or you can use this. Let's go ahead and use this. 5 squared is 25. That makes it -25 because there's the minus on it. 10 times 5 is 50, so we're going to do plus 50 and then minus 9. -25 plus 50 is 25. Minus 9 is 16, and so our vertex is at 5, 16, and we have completed the graph, and we have identified the function. Okay. Now now that we have a procedure, let's just do a couple more practice problems. Okay. So here is a graph that we have of a parabola. You can see that the x-intercepts are both labeled. You can see that the y-intercept is labeled. We have a vertex, but we don't have a label for it yet. We'll go ahead and work through that. Now, if you want to, you can pause this video, and you can try and run through this procedure and see if you can figure out the function yourself. All right, so I'm going to go ahead and do it. So the first thing we're going to do is we're going to write the form f of x is equal to a times x minus √1, x minus √2. Okay, so that's going to be f of x is equal to a times x. Well, we have two roots. We have -2 and we have 10. So let's do -2 first. Now note, x minus -2, that's x minus a negative. And minus a negative means plus. So we're going to put in x plus 2. Okay? And that makes sense because if we were to plug -2 in here, if we plug the root in, -2 plus 2 equals 0. And then 0 times the other root, or the other factor times a is all going to be 0. And that's what's important. Whatever will make this factor equal 0, that's the root. So we got to put in, this has to be a form of complement to -2. So -2 plus 2 is 0. And so we got x plus 2. Then we're going to do x minus the other root, which is 10. So that's x minus 10. And that makes sense because if we put 10 in here, 10 minus 10 is also 0. So this is our form. We're ready to go. Okay? All right, now here we want to identify the lead coefficient by doing this. This a is equal to whatever the y-intercept is. Well, our y-intercept over there is -40. So you can see 0, -40. And so we're going to do a is equal to negative 40 over, then we're going to multiply the two roots. We're going to multiply negative 2 times 10, and so that gives us negative 40 over negative 2 times 10 is negative 20. Negative 40 divided by negative 20 is 2. And so a is equal to 2. And so we're going to have now f of x is equal to 2 times x plus 2 times x minus 10. Okay? Now, we're going to distribute because we don't want it in this form. Well, this is a useful form for graphing, but we want our function to be in the standard form here. So we're going to distribute to identify the standard form. And so f of x is going to be equal to, we're not going to do the 2 yet. We're just going to leave the 2 there, but we're going to distribute here. X times x is x squared. X times negative 10 is negative 10x. 2 times x is plus 2x. We learned to do this in Unit 2, I mean, if we didn't already know how. 2 times negative 10 is negative 20. Actually, no, I think we learned how to do this in Unit 1. And so now this becomes, let me move this out of the way, 2 times x squared, negative 10 plus 2 is negative 8x, and then minus 20. And now when we distribute the 2, we get f of x is equal to 2 times x squared is 2x squared. 2 times negative 8x is minus 16x. And 2 times negative 20 is minus 40. And look, there's our y-intercept. Remember, the number that's down here, over here on the end, has to be the same number as our y-intercept. And so this is our answer. Now we can just identify the vertex here. Halfway between negative 2 and 10, add them both together. 10 plus negative 2 is 8, divided by 2 is 4. Therefore, this is going to be 4, comma. Now we're going to plug 4. We can either plug it in here, or we can plug it into the factored form. Let's plug it into the factored form. 4 plus 2 is 6, so this is a 6. 4 minus 10 is negative 6, so this is a negative 6. And that, by the way, if you're thinking, man, how come we always keep coming up with the same number except that one of them is positive and one of them is negative? It's because the vertex is halfway between the two. So it's 6 units away from each side, okay? And so we're going to have 6 times negative 6. That's negative 36. Negative 36 times 2 is negative 72. And so negative 72. Let's say we did it here instead. We come up with the same thing. 4 squared is 16. 16 times 2 is 32. Minus 16 times 4, that's 64. So minus 64. 32 minus 64 is negative 32. And you might be thinking, why do we always come up with the same number as what we had here, only it's the opposite sign? That's a feature of quadratics and the vertex. So we got negative 32 minus 40, negative 72, and so we have our answer. Okay? I'll try and do a supplemental video that has a whole bunch of examples here, but that's basically the same procedure. You should be able to do this with all of the quadratic graphs. And so now what you know how to do is you know how to take a function and sketch a graph, and now you know how to take the sketch of a graph and identify the function.